All right, we just finished 8.3. Now we're going to move on to 8.4, logarithmic functions. And we're going to start by writing the inverse function. The first step to finding any inverse is always to switch your x and y. And then we want to solve for y. The way we're going to solve for y is to change it from log form to exponential form. And the way we do this is the natural log is really the log with the base of e. So to rewrite this to exponential form, it's e raised to the x power is equal to y minus 2. And then the one step to getting y by itself is moving 2 over. And we get that our inverse function is y equals e to the x plus 2. Remember, if you're writing the inverse and you're starting with logs, then your inverse should be exponential. If you're writing the inverse and you're starting with exponential, it should be logs. So we look at number 8. I've got y equals log of x plus 12. Anytime you're given a log like this that does not have a base number, remember that's the common log and it has a base of 10. So we switch our x and y. I'm going to write log base 10, so remember that that number there is 10, y plus 12. So I've got it in log form. I've switched my x and y. To get it, my inverse equation, I now write it in exponential form. So it's my base of 10 raised to the x power equals y plus 12. To get y by itself, I subtract 12 to the other side, and we get y is equal to 10 raised to the x power minus 12. Now both of these could have also been done by solving for y by getting rid of the e, or getting rid of the natural log by taking this and doing e to the natural log. E to the x, this would have been canceled and you would have been left with y minus 2 down here and e to the x. Same here, if I wanted to get rid of log base 10, I would have done 10 to the x, 10 to the log base 10, and I would have been left with y plus 10 here and 10 to the x there. There's two approaches. It doesn't matter which way you do it, you'll still get the same answer in the end. Okay, next page. 8.5 is properties of your logs. And the first property is if you're multiplying, you separate them with an addition sign. If you're dividing, you separate them with a subtraction sign. And if you have an exponent, the exponent moves out front. So what I'm going to do is expand this. Expanding means I'm going to make it bigger. Since I have the natural log here, every single piece is going to start with the natural log. And I have 3y to the fourth divided by x to the third. So that's natural log of 3y to the fourth. Since I am dividing, I subtract natural log of x to the third. Remember, natural log should be in each of my pieces. Then I look at the first one. I look to see if I can break this down any further. Natural log of 3y to the fourth. I'm multiplying 3 times y to the fourth, so I have to separate the natural log of 3 from the natural log of y to the fourth with an addition sign. I have minus natural log x to the third. So I look at 3. 3 can't be broken down any further. Natural log of y to the fourth. I have an exponent, so I can move that 4 out to the front. I've got an exponent. I move that out to the front. No more pieces can be broken down, so this would be my answer as it's expanded. Remember, I'm making it larger. If the original piece has natural log, every single piece in my answer has a natural log. Condensing is going the opposite direction, so I've got multiple pieces and I want to condense it into one. So it's going to look like number 9 started. Notice in number 9 I have the natural log only once in the beginning, so when I condense this I should only have my log one time. Now here I have a number, an integer 2. The only way I could have got an integer of 2 with my logs is if I would have had a log. I look at these, I've got log base 5. So the only way this would have canceled if I would have had 5 squared. This would have been canceling to leave me with the 2. If I have a number out front, that 3 is the exponent on x, so that's x to the third, minus that 6 is the exponent on y, so that's y to the 6th. Make sure that you're really going step by step so you don't miss something. So here we've got log of 5, and we've got 5 squared, which is 25, plus, which means we're multiplying. Yeah, I'm going to write this over here to the side. So we're only going to have log base 5 once, and as we just said, we've got 5 squared, which is 25. We're adding x to the third. When we go back to our rules, adding means multiplication, so I'm going to take 25 and I'm going to multiply it by x to the third. Then I'm subtracting y to the 6th. Subtraction means division, so that's divided by y to the 6th. Remember, expanding, it's making it bigger with your log in each piece. Condensing makes it smaller, and you're only going to write your log one time. Last in 8.5 is your change of base. We can only enter in our calculator a log base 10 and a natural log. As we look at number 11, we don't have a base 10, we have a base 3. So what this says is if I can take log u divided by log of b, it's always this number on top, this number on the bottom. So we get log of 47 divided by log of 3. Don't try to simplify this, just enter this in your calculator, and you get about 3.505. As I said in the last video, make sure that you're doing this on your own as well. You're entering these numbers into your calculator so that you know how to get 3.505 as well. Next we have 8.6, and 8.6 is solving. We've got 2 times 3 raised to 2x is equal to 5. I want to get to that x. The 2x is being raised to the, or it has a base of 3. Only 3 is getting this exponent, the 2 is not. So the first thing I'm going to do is I'm going to move that 2 over, and we get 3 raised to 2x is equal to 5 halves, which is 2.5. It doesn't matter if you keep it as 5 halves or 2.5. Okay, so I want to get to the exponent. The only way to get the exponent is to cancel out the base of 3. The only way to cancel out that base of 3 is to do the log base 3. If I do that over here, then I've got to do it on the right hand side as well. Log 3 of 3 cancels, so my 2x is going to drop down. It's no longer an exponent, it's 2x equals log base 3 of 2.5. So then I want to get x by itself, so we divide by 2. When you enter this in your calculator, you want to be very careful. Remember, this cannot be entered in, so we have to take log base 2.5 divided by log base 3. That's our change of base formula. Take that entire thing and then divide it by 2, and we get x is about 0.417. Right, and then you also want to make sure that you're checking your answers. We're not going through the checking on the video, but make sure that you check for extraneous solutions. Number 13, we add 4 over. We get 3e to the negative x is equal to 13. We divide by 3, and we get e to the negative x is equal to 13 thirds. The last one I simplified it to 2.5. When you have a third, you have a repeating decimal, so keep it as 13 over 3. And I want to get to that x there, so I have to get rid of the e. The way to get rid of the e is to take the natural log, so I natural log each side. The natural log of e cancels, so my exponent drops down, so I've got negative x is equal to the natural log of 13 thirds. Now you're not going to use the change of base for that one, because it's not a base of 13 and a base of 3. It's the natural log of 13 thirds. Divide by a negative 1. X is equal to the natural log of 13 thirds divided by a negative 1, which is about a negative 1.466. Again, check your solution. Number 14, we want to get to x. So I want to get that natural log piece by itself. I move the 3 over. We've got the natural log of x is equal to 5. I want to get inside to get to that x, but right now it's the natural log of x. I can't just divide by the natural log. I'm taking the natural log of x. What I want to do is get rid of the natural log. I need to undo it. The inverse, or the opposite, of the natural log is e. So if I start with the log, the inverse of logs are exponents. The inverse of exponents are logs. So I'm going to take e raised to that power. So I'm going to have e raised to the 5th power. E of natural log cancels, so the x drops down. I've got x is equal to e to the 5th power, and e to the 5th power is about 148.413. Make sure you check your answer. Next, we want to get inside there, so we divide by 5. Log of x minus 2 is equal to 11/5. Remember, it doesn't matter, you can use decimals, you can use fractions, so I'll just leave it as a fraction this time. Even though it doesn't say it, this really has a base of 10. So to get rid of the log, just the way I got rid of the natural log here, I have to do the opposite. So I want to take 10 raised to that power. So I went 10 raised to the 11/5 power. Alright, so that's going to cause our 10 to cancel and have x minus 2 brought down. And then I'm just going to make this simpler. I don't want to have the fraction there. So 11/5 is really 2.2. We add 2 to each side. So x is equal to 10 raised to the 2.2 power plus 2. So x is going to be about 160.489. Alright, our last problem is a logistic growth problem. And to do this, we are going to cross multiply. So we put 9 over 1. So that gives us 9 times 1 plus 2 e to the negative 3x power is equal to 4 times 1, which is just 4. Now what I would do is I would get rid of the 9 right away. I would divide both sides by 9. Now this fraction isn't like the last one, doesn't become 2.2, so I have to leave the fraction. So that's 1 plus 2 e to the negative 3x is equal to 4/9. Then I want to move the 1 over. So I subtract 1. That leaves us with 2e to the negative 3x is equal to a negative 5/9. Then we want to divide by 2. And we get e to the negative 3x is equal to a negative 5 over 18. And now I want to get to that exponent, so I have to undo the e. I have to undo that base, so we know the opposite or the inverse of e is the natural log. So I take the natural log of each side. The e's cancel, so I've got a negative 3x is equal to the natural log of a negative 5/18. Last step, divide by a negative 3. And we get x is equal to the natural log of a negative 5 over 18 divided by a negative 3. And hopefully you a red flag went up, and you know that you can't take the natural log of a negative number. You can't take a log of a negative number. So this piece right here is not going to be able to happen. So that's what's going to tell you that you have no solution. Okay, that is all for your Chapter 8 review. Make sure that you study for your test.